Okay, good morning, class. So today we're looking at trigonometry, sine, cos, and area rule. We're looking at the examples for exercise 10.2. And exercise 10.2 is on page. Wait, what happened now? It's 10.2 on page 336. And I'm reading from page. Example 1 is on page 334. Okay. So now we're looking at the area rule. Okay. So we spoke about the area of a right angle triangle is going to be half a base times height. And they derived this formula here. And we spoke about that formula as well. So we came to the conclusion that the area in any non-right angle triangle is that the area in any non-right angle triangle ABC would simply be of AB sine C. Let's see, we got angle C, which is also equal to half. If you got angle B, what will it be? Half B's AC sine of angle B. Remember, if this is capital A, this will be lowercase a. This capital C, lowercase b. So if you got that angle, it must be two lengths and an included angle. So it's going to be half AC sine B, which is also equal to, if we had angle A, what would it be? Half BC sine of angle A. Alright. Let's see here. Yeah. So in example 1 on page 334, we are asked to calculate the area of the triangle connected to two decimal places. So do we have two lengths and included angle? Yes. So the area is going to be half BC sine of angle A. So it's simply going to be half 5 times 7 sine of 48 degrees. Okay, so it's going to be half times 5 times 7 sine of 48. Going to give you 13. Is that correct? 13.01 degrees. 13.01 centimeters square. Is that they're talking about area? Let's check if that's correct. Yes. Okay. Let's go to example 2. In example 2, we are told. Is example 2 on the same page? Example 2, we are told that to calculate the area of triangle connected to two decimal places in triangle PQR, which angle P is 125, angle Q, lowercase q is 48.1, and R is 32.7. How do we work out the area of this triangle? Do we have two lengths and an included angle? Yes. So it's going to be a half RQ or QR sine of angle P. So it's going to be a half. R is 32.7, Q is 48.1, sine of 125. Alright, so let's do this. So it's half times 32.7 times 48.1 sine 125. Gives you 644, 29. 21. Sorry. centimeters. Okay. Is there any confusion here? Let's look at example 3. Example 3 is on page 335. This way. Here they ask you to calculate the length. Now we work in reverse. Not so. Calculate the length of JK. Triangle JKL has an area of 27 centimeters squared. So if you are wanting to work that out, the area of that triangle, given this information here, is the same area as that triangle, given that information there, and so on. Why? Because that's exactly the same triangle. You guys understand? So, when we're doing the area, we need to know two lengths and an included angle. Not so. So, is that the case here? Yes. Because they want us to calculate JK. We got JL and we got the angle J. Okay, so the area of the triangle is simply of JL times JK sine of angle J. So the area of this triangle is 27 is equal to half. JL is 9. JK is what we're calculating, sine of 30 degrees. So to get JK on its own, I divide both sides by half times 9 sine of 30. Half times 9 times sine of 30. Okay. So JK sine of 30, of course, is half. 9 is 3. I think the answer is 12. Let's check that. It will be 27 over 0.5 times 9 times sine of 30. 12 centimeters. Be the answer. Okay. Any confusion here? Right, let's go to the next example. Example 4. Example 4 is on page 95 as well. Okay? On the same page, yeah? Okay. So here we are told that calculate two possible values of G. Okay, again we have two lengths and included angle there. Okay. So we wanted to calculate angle G. Correct to the nearest whole number if the area of this triangle is 68. Yes?
Sorry, sir. Can do the roll, please.
Okay, so FG is 12 and GH is 14. So how do you calculate the area of a triangle? It's going to be half. The area is equal to half. FG times GH sine of angle G. So the area is 68 centimeters squared equal to half FG, which is 12 times GH, which is 14 sine of G, angle G. So I divide both sides by 12 times 14 times half. So that cancels. So sine of G is equal to, so it's 68 over half times 12 times 14 gives you 17 over 21. Yes? Okay. So as we work out angle G, it's going to be my reference angle, doesn't it? Right, so angle G is equal to arc sine of 17 over 21. Gives me 54, 05. So the whole number, so it's 54 degrees. Now, remember that sine is positive here, not so. In which quadrant is sine positive? 1 and 2. So if it's in quadrant 1, the angle is acute. If it's quadrant 2, the angle is Obtuse. So that can be an acute or an obtuse angle. So therefore G is equal to 54 degrees if it's acute, or angle G is equal to 180 minus 54. And 180 minus 54 giving the answer 126 degrees. Okay. So any confusion here? No. Alright, so that basically brings us to the end of the examples for exercise 10.2. Okay, and with that you guys have completed that already. Not so? And we went on to the next work as well. No? So I'm going to do that recording now as well.